So now we are looking at example number 8 on practice sheet 3. Tickets to a local movie were sold for $5 for adult tickets. Just writing down this information. And $3 for student tickets. So we know the price of the individual tickets, $5 for adult tickets, $3 for student tickets. Now here's what we're told. 150 tickets were sold altogether. And the amount of money it was sold for sold for a total of $610. And we want to know how many adult tickets were sold and how many student tickets were sold. This is a very typical type of example you might see. The numbers will be different, but the concept is the same. You have something that you're selling or is worth a certain amount of money, and they're two different items, and we know that how many are sold and how much is made. We want to know how many of each individual item was sold. So let's write a legend. Let's decide what our variables are going to represent. I always like to use X and Y. So let's remember what we're looking for. How many adult tickets, how many student tickets. What we're looking for is what we use to write our variables. Let X be the number of adult tickets that were sold. And let Y be the number of student tickets that were sold. Okay? Be very clear in your mind what your variables represent. Okay? So we know X is how many adult tickets were sold. Y is how many student tickets were sold. Now remember, the first statement we had was that 150 tickets were sold. So that equation becomes X plus Y equals 150. In this expression, this equation has nothing to do with how much the tickets were sold for. It's just how many there were. And the total of the X and the Y together is the 150. So that gave me the equation X plus Y equals 150. Okay, now we have to deal with the money part. Now when we're figuring out how much money is made, remember it's not only how many tickets of each kind were sold, but the price of each ticket. So when it comes to the adult tickets, the amount of money they made on the adult tickets is 5X. $5 for each ticket times X, the number of tickets, adult tickets that were sold. When it comes to the student ticket, it becomes plus 3Y, because the student tickets are $3 a piece. The 5X plus the 3Y is the total amount of money that was made by selling the tickets. Well, we know what that is. That's 610. In other words, when I include the price of the tickets, I have to then use the total amount of money. Money with money. No money with no money. Now it's just a matter of solving the system of equations. We wanted to find both the X and the Y because it said how many adult tickets and how many student tickets. Let's use the elimination method. Let's eliminate the Y's. Okay, if I want to eliminate the Y's, let's multiply this by 3 and this by 1. Because this has a coefficient of 1, so we multiply this by 1. This has a coefficient of 3, so we multiply this by 3. But since both of them are positive, one of these has to be a negative. It could be the top number or the bottom number, it doesn't matter. I'm putting it with a 3, so I'm going to multiply the top equation by -3 to get -3x minus 3y equals, don't forget, -3 times 150 is -450. Don't forget to multiply everything by the -3. Multiplying by 1 just leaves everything the same, so this stays 5x plus 3y equals 610. Okay, now we combine. -3x plus 5x gives me 2x. -3y plus 3y, that cancels out. Well, we wanted to eliminate the y's, that's what we said. Let's get rid of the y's. And that equals -450 and 610 when we combine them gives us 160. And now I divide both sides by 2. So that gives me x equals 80. So let's go back. The number of adult tickets sold were 80 because X standard for how many adult tickets were sold. But it said how many adult and how many students. Let's see how we can figure out what the student tickets were. Let's go right over here. Let's take this equation, x plus the y equals 150. So the x we know is 80 plus y equals 150. And I'll subtract 80 from both sides. And that'll leave me y equals 70. So they sold a total of 80 adult tickets and 70 student tickets to this concert, to this movie. Does anybody have any questions about how to do this? This type of question is very often asked. As I said, it'll be different numbers, but it'll be the same idea. Let's try another example that's similar. Number 9. This was number 8. We're now doing number 9 on practice sheet 3. Okay, we're now going on to number 9 that reads like this. Chad sold 30 decorated sweatshirts. Let's call them sweatshirts. SW. At a craft show. White ones cost $10. Black ones cost $15. Okay, so he has 2 types of sweatshirts. Some are white and some are black, and he sells them for different prices. He sells the white ones for $10 and the black ones for $15. Now he sold 30 altogether. How much money did he make altogether? He made $390. He received a total of $390 for the shirts. How many black shirts did he sell? So even though it's not tickets, it's again a situation where there are 2 types of things that we're selling, and we want to know, we know how many are sold altogether. We know how much money we make altogether. We want to know individually how many of the black shirts. We don't even care about the whites, we're just looking for the black. Okay, so let's look at this. Let's set up a legend. Let's decide what our variables represent. Let's call it W and B for a change. Let's call W the number of white sweatshirts that were sold. The number of white sweatshirts. And let's call B the number of black sweatshirts that were sold. Okay, here's my legend. I have W for the number of white shirts, B for the number of black shirts. I know a total of 30 shirts were sold. 30 sweatshirts were sold. So it must be that W plus B equals 30. It has nothing to do again with the money. It's just how many were sold. Okay, now let's talk about the money, the 390. How did we get the 390? By $10 for each white shirt, so that would be 10W. That's how much you got for all the white sweatshirts, plus 15 times the B, so that'll give us how much money he made on the black shirts. Let me make this one clear. That is going to give me my 390. Similar setup, different numbers, but the same concept. Again, let's get rid of, well, in this case, we want to figure out what the black is. They asked us specifically for how many black shirts there are. So that being the case, let's get rid of the W. So if I want to get rid of the W, let's multiply this one by the 10 and this one by the 1. Again, they're both positive, so we have to use a negative with one of them. And again, it doesn't matter if I use a negative with the top or with the bottom. So let's do this time with the bottom. And my top equation becomes 10W plus 10B equals 10 times 30, which is 300. And the bottom equation multiplied by -1 gives me negative 10W minus 15B equals negative 390. And when I add these two equations together, the 10W and the negative 10W cancel out. Well, that's what we were trying to do. The 10B and the negative 15B gives me negative 5B. And 300 plus negative 390 gives me negative 90. And I divide both sides by -5. And it gives me B equals 18. In other words, he sold 18 black sweatshirts. If you want, you could then figure out how many white he sold, but you could have rewrite. They only asked for the black, so we don't have to do anything more on that. I hope you see how similar that is. Okay, let's try the last example, which is a little bit different than the other two. This is example number 10. Here's what number 10 says. The perimeter of a rectangle is 10 meters. Okay, so here's my rectangle. Let's draw a picture. Its perimeter is 10. If the length was doubled, and the width is increased by 10, the perimeter is 36. What are the length and width of the rectangle? Okay, so we start with a smaller rectangle. and then we make its sides bigger, then we end up with a bigger rectangle, and we want to know what was the original length and what was the original width. Let's call the original length of this L, and the original length of this, and the original width W, L and W. If this is L, then this is also L. The two opposite sides are equal. And if this is W, this is also W. So my perimeter becomes, remember we add all four sides, W plus L plus W plus L. Add them all four up, but they told me what it's going to add up to. The perimeter is 10. Or if we simplify, this becomes 2L plus 2W equals 10, just combining the like terms. That's in my original rectangle. Let's talk about this new rectangle. In the new rectangle, the length was doubled. So if this length was L, doubled means multiply by 2. This has to be 2L. And if this is 2L, that means this side is 2L as well. The width was increased by 10. Now, remember, we could say either it's 10 more or increased by 10. That means we added 10. So if the original width was W, this new width is W plus 10. And then this one would also be W plus 10. And they told us that that perimeter is now 36. So let's add this all up. We have 2L plus W plus 10 plus 2L plus W, I'm going to have to go over here, plus W plus 10. So I'm adding all four sides up, and that's going to give me my perimeter of 36. Now, combining the like terms, there's a 2L here and a 2L here, so that gives me 4L. A W plus a W, that's a 2W. And a 10 and a 10, which gives me 20. I've added up all the like terms, and that adds up to 36, because we know the perimeter is 36. Now, I'm going to subtract 20 from both sides to get all the numbers together. So my second equation comes out to be 4L plus 2W equals, well, 36 minus 20 is 16. Well, now I have two equations. My original equation, 2L plus 2W equals 10. And my second equation is 4L plus 2W equals 16. Okay, and now we want to get rid of either the L's or the W's. Let's get rid of the W's. Now, they're really, I could multiply this by 2 and this by 2. But if I notice, they already have the same number, so I don't have to multiply them by anything except I need one of them to be multiplied by a -1. I can leave the other one. Sometimes there's just a much simpler way. I could always use my standard way of multiplying it by the opposite coefficient, but if I see a simpler way, we may as well do it. Multiplying that top equation by -1 gives me -2L minus 2W equals -10. And now when I add them, 4L and minus 2L give me 2L. 2W and -2W cancel out, and that's all we're trying to do. We're trying to get rid of those W's. And 16 minus 10 is 6. So that gives me L equals 3. So the original length on the rectangle is 3. Now, what about the width? Well, let's go, let's say, to this equation, 2L plus 2W equals 10. So 2 times 3 plus 2w will give me 10. 2 times 3 is 6. 6 plus 2w equals 10. I'll subtract the 6 from both sides, which will give me 2w equals 10 minus 6, which is 4. And that gives me w is 4 divided by 2, which is 2. So the length was originally 3, and the width was originally 2. And that was a little bit harder, but if we just followed through, we were able to do a system of equations and solve our system of equations. That pretty much takes care of the type of examples that you might see on systems of equations. Is there anybody who would like to ask a question? Okay, so then let's go back to what we were talking about on Thursday, our discussion of polynomials. I'm going to put two problems on the board for you to do while I take attendance. Okay. Question number 1. Subtract 2x squared minus 5x third plus 7x plus 1 from 3x to the third plus 3x minus 3. Okay, let's see if you can do that problem. While I take attendance, I'm going to put the recording on pause. So we have to put the 3x to the third plus 3x minus 3 first, and then minus the 2x squared minus 5x cubed plus 7x plus 1. If you notice, this is written in what we call descending order. This is not, things are not in the right order, but it's fine to do it this way. Don't forget, it's understood as if there is a 1 in front of each of these parentheses. When there's no number in front of a parentheses, it's understood as if there's a 1 there. So multiplying everything in the first parenthesis by 1 just leaves it to 3x cubed plus 3x minus 3. Multiplying everything in the second parentheses by -1 will give us negative 2x squared plus 5x to the third minus 7x minus 1. Basically, what it's doing is changing all the signs. And now we look for our like terms. So we have a 3x cubed here and a 5x cubed here. Those combine to 8x cubed. The next thing I have is an x squared term. There's only one x squared term, so I just bring it down. It's minus 2x squared. Then I have a 3x and a negative 7x. Those are like terms. 3 minus 7 is negative 4. So that gives me negative 4x. And finally, the negative 3 and the negative 1 are like terms. That gives me minus 4. So my final answer, which is actually written, that I wrote in descending order, is 8x to the third minus 2x squared minus 4x minus 4. Remembering that the degree of this polynomial is 3 because that's the highest exponent that I see. I hope most people did get that correct. Okay, so, and the only difference between adding and subtracting of polynomials is whether you add the coefficients or you subtract the coefficients. But basically, you leave the letter parts alone, you just deal with the numbers, the coefficients. Okay, so we talked about adding and subtracting. We started talking about multiplying. Let's talk about multiplying of polynomials. Let's say I have 4x minus 7, that one polynomial, times 2x plus 3 as our other polynomial. Notice when we put our two parentheses right next to each other without any sign in between, it means that the operation is multiplication. We are actually multiplying a binomial by a binomial. Now I'm going to talk about the general way of multiplying polynomials, and then we'll talk about the specific, how it specifically affects binomials. When we want to multiply any polynomial by another polynomial, what we have to make sure is to multiply every term in the first polynomial by every term in the second polynomial. So if I have 4x minus 7, I'm first going to multiply the 4x by each of the terms of the second polynomial. I'm going to distribute the 4x. So 4x times 2x will give me 8x squared. Remember, when you're multiplying the letters, you add their exponents. And if there's no exponent that you see explicitly there, it's understood that the exponent is 1. So 1 plus 1 gives you 2. So this is 8x squared. Then we take the 4x and multiply it by the 3. That will give us 12x. 4 times 3 is 12, and we just bring the x over. We have now distributed the 4x to each of these terms. We go back. We take the next term, which is -7, and distribute the -7 to each of these terms. So I do -7 times 2x, that gives me -14x. And -7 times 3, which gives me -21. Notice there were 2 terms of the first term, parentheses, 2 in the second. 2 times 2 gives you 4. So when I finish my multiplication, I end up with 4 terms. Usually when that happens, there are some like terms. If you notice, the 12x and the -14x are like terms. So I can combine them, and I'll get as my final answer 8x squared. 12x minus 14x is -2x minus 21. Don't try and add the x squared and the x, because those are not like terms, but these were like terms. This is my final answer. Notice we multiplied 2 binomials. My answer turned out to be a trinomial. That very often happens. Now, actually, when we multiply 2 binomials, sometimes you've heard of this term, we multiply using FOIL. I want to show you that what we actually just did is FOIL. Let's go back. FOIL stands for first. We take the first 2 terms of our parentheses and multiply them. The 4x times the 2x, that gave us the 8x squared. The O stands for outer. Outer means things that are far apart. If you look in these 2 binomials, the furthest apart terms are the 4x and the 3. We have to multiply the 4x times the 3. That gave us the 12x. That's our second multiplication. Then we have an I. I stands for inner. When we talk about inner, we're talking about the insidemost terms, the terms that are close together. Now, if you notice, that would be the -7 with the 2x, because they really are right next to each other. The only thing that's separating them is the parentheses. So now we multiply the inner, the negative 7 and the 2x. That gave us a negative 14x. And finally, the L stands for last. That means the two last terms in each of the parentheses. So this will be a negative 7 times the 3, and that's the negative 21. So actually, when we're doing this FOIL, what we're really doing is just using the distributive property twice. Again, after you've done all the multiplications, you look to see if there are any like terms. You combine the like terms. Again, FOIL is just a reminder to do 4 multiplications when you have 2 terms. Now, what would happen if you didn't have 2 terms, but you had a trinomial and a binomial? What if I gave you a problem that looks like this? Suppose I gave you 3x plus 5 times 2x squared plus 4x minus 2. Suppose I gave you a binomial times a trinomial. Well, obviously you're not going to use FOIL on that because FOIL specifically means 2 terms times 2 terms, 2 binomials. But the concept of how we went about doing it is the same. We're going to take each term in our first parentheses and distribute it to each of the terms in the second. So first I'll take the 3x and multiply it by the 2x squared. 3 times 2, those are my coefficients, is 6. X times x squared. Remember, this is understood to have an exponent of 1. 1 plus 2 is 3. So it's 6x to the third, or 6x cubed. Then I take the 3x and multiply it by the 4x. So 3 times 4 is 12. And x times x is x squared. And finally, I take the 3x and multiply by the negative 2. 3 times negative 2 is negative 6. And there's only one x there. We don't have any to multiply by. So it becomes negative 6x. We have now distributed this 3x to each of these terms. We go back and we take the 5 and multiply everything by the 5. 5 times 2x squared will give us 10x squared. The only thing you have to be careful about are those signs, and to be careful to be organized. 5 times 4x is 20x. And finally, 5 times negative 2 is negative 10. Now, just like we did before when we were doing binomials, we have to see, are there any like terms? Well, the first thing I see is an x cubed. There's no other x cubed term, so that stays 6x cubed. Now we have a 12x squared. We can combine it with this 10x squared. So 10 and 12 gives me 22. So that becomes 22x squared. I have this negative 6x. I can combine that with a 20x. Negative 6 and 20 is plus 14. So this becomes plus 14x. And just minus 10. There's nothing to combine that with. Notice in the end, I end up with not 6 terms, but only 4 terms because there were like terms. And again, this is in descending order. This is a cubic polynomial, something that has a degree 3. Okay. Any question about any of these? Okay, let's do a couple of other interesting multiplications. First of all, when you're multiplying binomials, sometimes you get a situation like this. I have a 3x plus 2, and I'm multiplying it by 3x minus 2. You look at your two binomials, and they look almost identical. The only difference between the two binomials is that one has a plus between the two terms, and the other has a minus. They are not negatives of each other, because in order for this to be the negative, the 3x would have had to be negative as well. No, these are what we call conjugate binomials. Two binomials that are identical except for the sign between them. Now, normally what I would do is regular FOIL. There's the two binomials. So let's look what will happen when we do the FOIL. First, 3x times 3x is 9x squared. Outer, 3x times negative 2 is negative 6x. Inner, 2 times 3x is plus 6x. And finally, 2 times negative 2 is negative 4. And I look to see if I can combine any like terms, and the two middle terms, negative 6x and positive 6x, just cancel each other out, so that my final answer becomes 9x squared minus 4. We're used to seeing multiplying of binomials. If you multiply two binomials, you really usually expect to see a trinomial as your answer. But when you are multiplying conjugate binomials, your answer will not be a trinomial, your answer will be a binomial, because your two middle terms, the inner and the outer, are going to cancel each other out. Now, if I know this is going to happen, then I can do my work much quicker. I see these are conjugate binomials because they're the same except for the sign. Then I don't have to do the whole FOIL because I know part of them are going to cancel out. I just have to do the first, the 3x times the 3x, it'll give me the 9x squared. And the last, the plus 2 times the minus 2 is negative 4. So if you recognize that what you have are conjugate binomials, then you can save yourself time in the multiplication because you don't have to do the inner and the outer. They're going to cancel each other out in any case. Okay. What if I had given you something like this? What if I gave you an expression where I want to multiply three things together? Suppose I have x minus 4 times x plus 3 times x minus 2. How do I go about multiplying three polynomials? Well, I'm going to tell you what to do, and I'm going to let you do it. What you do is you take your first two and multiply those together. Get your answer for multiplying those two together, and take that answer and multiply it by the third. This is not a matter of distributing, because there's no pluses in between them. You have to multiply. It's like multiplying. If you wanted to multiply 2 times 3 times 4, for example, you would first do the 2 times 3, which would give you 6. And then you take the 6 and multiply it by the 4 to give you your answer, 24. So when you want to multiply three polynomials, you have to do multiplication. First the first two, get an answer, and multiply by the third. I'm going to give you a few minutes to try that on your own. Okay, I think we had enough time. Let's see if we can do this now. I'm first going to multiply the x minus 4 times the x plus 3. If I do that, I'll use FOIL. I'll do x times x is x squared. At outer, x times 3 is plus 3x. Inner, negative 4 times x, which is negative 4x. And negative 4 times 3 is negative 12. And I see these two terms are like terms. I get x squared plus 3x and minus 4x is minus 1x, or just minus x, and minus 12. And I want to multiply this now by x minus 2. That means I have to take each term in my first parentheses and multiply it by each term in the second parenthesis. So first I'll start with the x squared. X squared times x will give me x to the third. Remember, I'm adding exponents. Then I do x squared times negative 2. That gives me negative 2x squared. Okay, I've finished multiplying by the x squared. I'm now going to multiply everything by negative x. So negative x times x is negative x squared. And negative x times negative 2 is positive 2x. Don't forget, a negative times a negative is positive. Okay, I've multiplied everything now by the negative x. I'm now going to multiply everything by negative 12. Negative 12 times x is negative 12x. Negative 12 times negative 2 is positive 24. So here I have to now combine my like terms. I have an x to the third, only one of those, so that's that. Now I have a negative 2x squared and a negative x squared, which is a negative 1. So negative 2 and negative 1 is negative 3x squared. Now I have a 2x and a negative 12x. So 2 and negative 12 is negative 10x and plus 24. I hope you all got that answer. X cubed minus 3x squared minus 10x plus 24. Any questions about this? So I think we're pretty well established in terms of multiplying polynomials. Just remember, you basically keep using the distributive property, multiplying everything in one parentheses with everything in the other. Also remember, when you're multiplying, what you do to the exponents is you add the exponents. Okay, so far in terms of polynomials, we've added, we've subtracted, and we've multiplied. Instead of going straight to division, which is pretty complicated, and we're going to do it a little bit later in the term, we're going to do something that's called factoring. What do we do in factoring? I'm going to demonstrate it just with regular numbers, but we're going to do it with variables. In factoring, what we do is we start with a number and try to figure out what were the original numbers that we multiplied that give us this answer. It's not exactly division, because with division, you always start with the original number and what you're dividing by. Here, you're just starting out with one number and trying to think what originally you multiplied to get this answer. So sometimes you can figure out one of the factors. For example, I can see that one of the factors of 15 is 3, because if I I can evenly divide 15 by 3. 15 is divisible by 3. Somehow I figured out one of the factors. Well, if I know one of the factors, I can always figure out the other factor, because if I take the 15 and divide it by the 3, I get the other factor, which is the 5. So the two factors of 15 are 3 and 5. Notice, if we know one, we can figure out the other using division. But it's not only a division problem, because there's a step before the division. You have to figure out what is the original, what is one of the original factors. Once you have one factor, then you can use division to figure out the other factor. Okay, so how does this apply to polynomials? Well, one of the first things again, the whole point of factoring is to take a polynomial with a lot of different terms and break it down into the original polynomials that you multiply to get that answer. In other words, we're starting with the answer and going to the question. So let's say I gave you a polynomial that looks like this. 10x fourth minus 15x cubed plus 5x squared. I have a trinomial, 10x to the fourth minus 15x cubed plus 5x squared. The first type of factoring that we find or we look for, and it's always going to be our first step. The first type of factoring we want to do is something called a common factor. Sometimes it's a common monomial factor, that's the most common. We'll even sometimes have common binomial factors. But how do we do this? Let's first work about it. First, common monomial, a single term. Here's what we do. We take first the coefficients, the 10, the 15, and the 5, and try and find the largest number that goes into each one of those numbers. 10, 15, and 5. Obviously, the common factor of those three numbers is 5. 5 is the largest number that will go into all three of them. That's why it's called a common factor. It has to be a factor of each of them. Once you've done the coefficients, the letters are actually easier. First, so let's say, well, in this case, it's just x's, but sometimes you have more than one letter in it. Let's look at the x's. Make sure each of the terms has an x in it. Well, they do. In that case, the common factor, it will be the x with the lowest exponent that you have. This is a 4, this is a 3, this is a 2. 5x squared, the x to the 2, is going to be the common factor, the greatest common factor. Notice if there would be y's, we do the same thing with the y's. Once you've decided what your common factor is, you then have to break up your original polynomial into two pieces. That when I multiplied them, they gave me this. So to find what the other factor is, we have one factor, we have the 5x squared. To find out the other factor, we're going to divide each of the terms by the 5x squared. It's like the reverse of the distributive property. You're undistributing the 5x squared. So we divide the 5 into the 10. That gives me 2. The x squared into the x fourth. Remembering when you're dividing the letters, the variables, what you do is you subtract the exponents. 4 minus 2 is 2. So the first term becomes 2x squared. Then we divide it into the second one. Again, reverse of distributive. 5 into negative 15 is negative 3. X squared into x cubed. Well, 3 minus 2 is 1. It's x to the 1, which is just x. And finally, 5 into 5, that cancels out. X squared into x squared also cancels out. The letters cancel out when you subtract their exponent, you get a 0. That means they're canceling out. But since you're canceling out using division, you get a +1. It's not 0. You only get 0 when you cancel out with subtraction. We're not subtracting. We're dividing 5x squared into 5x squared. That gives me 1. And my answer to the original problem becomes 5x squared times 2x squared minus 3x plus 1. We have taken our original polynomial and we broke it down into what it was originally being multiplied before, basically taking the answer and breaking it down into the original question. Let's see if you can do this problem on your own. 6x to the 4th y squared plus 18 x to the 3rd y 3rd minus 24 x squared y 4th. Let's say I gave you, let me erase this because it looks a little too messy there. I want to factor this polynomial. Again, the first thing I always look for is a common factor. I might have figured out what the common factor is and factor it out. I'll give you a few minutes. All right, let's see if we can do this together now. We want to find whenever we're asked to factor, the first thing we're always going to try and find is the common factor. So we look first at 6, 18, and negative 24. We look at the coefficients, and the largest number that goes into all three of them is 6. Then we start working with the letters. Now we have two letters that we're dealing with, two variables. We have an x and a y. Let's first deal with the x's. We have an x fourth, an x cubed, and x squared. The lowest of all of those is the x squared, so x squared is our common factor. And then we look at the y's. We have a y squared, a y cubed, and a y to the fourth. Again, the lowest one is the y squared. So we have found our common factor of 6x squared, y squared. Now we have to figure out what we should put inside our parentheses as the polynomial that we multiplied the 6x squared, y squared to get this whole expression, which means we have to divide this into each term. So 6 divides into 6, it cancels out. X squared divided into x fourth. Remember, when you're dividing, you're subtracting the exponents. 4 minus 2 is 2, so that gives me x to the 2. And now we have y squared divided by y squared. Again, when you subtract their exponents, you get 0. It means it cancels out. The y squareds are canceled out. So the first term in my parentheses is x squared. Now I take the second term. 6 into 18 is plus 3. X squared into x cubed is x to the 1, or just plain x, because 3 minus 2 is 1. Y squared into y cubed is y to the 1, or just plain y. So my next term becomes 3xy. And finally, 6 into negative 24 is negative 4. X squared into x squared cancels out. Y squared into y fourth is y squared. So my answer in factored form is 6x squared y squared times x squared plus 3xy minus 4y squared. You could see if this is right by if you multiplied it back, you should get the original examples. So that's what's called factoring out a common monomial factor. The original thing that we factored out is a monomial, a single term. Now, sometimes you can see something that looks like this. Seven a times x minus 5 minus 2b times x minus 5. What we would normally do in such a case would be to try and remove the parentheses. But if we want to factor, what we sometimes look for, we look for a common factor. And in this case, the binomial x minus 5 is a common factor here. The x minus 5 is being multiplied by this 7a, and it's also being multiplied by the negative 2b. So just like I factored out a common monomial factor, I can factor out my common binomial factor. And usually it's even a simpler process because it's just right up there in front of you saying, here I am, x minus 5 is a common factor. So put that x minus 5 in front. And when I divide the x minus 5 into this term, the x minus 5 cancels out, and all I'm left with is the 7a. And over here, when I divide the x minus 5, again, it cancels out, and what I'm left with is minus 2b. In other words, I was able to factor this strange-looking expression into a product of two binomials. So we look for not only a monomial common factor, we also try to find, if it's possible, a binomial common factor. Now, where this really usually comes up is in something called grouping. I want to show you because usually you don't see this type of thing, but you might see something that looks like this. Suppose I give you something that looks like this. X third plus 2x squared plus 9x plus 18. This method of what's called factoring by grouping is usually used when you're asked to factor something that involves 4 terms. It's not a binomial, it's not a trinomial, it has 4 terms. Now, like in any expression, when you want to factor, the first thing you're going to try and find is a common factor. Well, a common factor, well, this is an x, so I have to have an x in each term, and my last term doesn't have an x. So there's no common factor that works for all 4 terms. When that occurs, what we can sometimes do is split the thing in half. Put a line right down the middle. And look at your first term. We're making 2 groups. In my first group, look for a common factor. If you notice, between these 2 numbers, the x cubed and the 2x squared, there is a common factor, not of a number, but of the letter of x squared, because the lower exponent is x squared. So factor out that x squared in the first group. X squared into x cubed gives me x. X squared into 2x squared gives me plus 2. Remember, this is as understood to have an exponent, a coefficient of 1, and 1 into 2 gives you 2, and the x squareds cancel out. Then go to your second group. Forget about your first group, go to your second group. You have a 9x and an 18. And think, is there a common factor in that second group? And yes, there is a 9 that goes into both terms, but there's no x's, so it's just plain 9. And 9 into 9x gives you x, and 9 into 18 gives you 2. And what's happened, and this doesn't always happen, but if it does happen, that's what grouping is about. The 2 binomials that you see here, the x plus 2 here and the x plus 2 here, are a common binomial factor. And just like we did before, we can factor out that common factor of x plus 2. And in the first group, I'm left with x squared. Remember, you just write what's on the outside, so it's really easier. And in the second group, what you're left with is plus 9. And we're able to factor this using grouping into 2 separate parentheses, two binomials. I think we have a few minutes left, so let's see if we can try one to get, you can try one on your own. Try this example. Three xy squared minus 6y squared plus 4x minus 8. See if you could factor this with grouping. All right, let's do this together. Again, I look at first I look at the whole thing as a unit. This has a 3 and a 6, but 4 doesn't work. So there's no common factor for the whole thing. Again, this has x's, but now everything has x's, not everything has y's. There's no common factor for the whole expression. So we're going to try and break it up into two groups and see if we could factor it by groups. So take my first two, the 3xy squared and the minus 6xy squared. First of all, there's a common factor of 3 because 3 goes to 3 and to 6. There's no x in both of them, but there's a y squared in both of them. So 3y squared is my common factor for this group. Dividing the 3y squared into the 3xy squared gives me x, because the 3's cancel and the y squareds cancel. And the 3 into the negative 6 is minus 2, and the y squareds cancel as well. So the first group can be factored into 3y squared times x minus 2. Then we go to our second group. There's a 4 and an 8, so 4 is certainly a common factor of both of them, but there's now x's in both of them, so it's just plus 4. 4 into 4x gives me x. 4 into negative 8 gives me negative 2. And now I see that my common factor between the two is a common binomial factor of x minus 2. I can put the x minus 2 in one parenthesis, and then what I put in the other parentheses are the things that are on the outside, the 3y squared and the plus 4. And we've factored this using grouping. So we use grouping when we are given something with 4 terms and there's no common factor in all 4 of them, but we could do a common factor in each of the first group and the second group. On homework sheet 4, I would like you to do 1 through 13. Again, this does not have to be handed in, but you have to know how to do it. I don't think I sent you out the answer key yet, but I will send you out the answer key. Also, don't forget that I extended the due dates on all the examples, all the exercises on Delta Math. The test one I extended until tonight at 10 o'clock, and the other things I've extended until I think Friday, because I saw there were some people that are having trouble finishing up. If you didn't get it to finish it up before because you were shut out because of the due date, I did extend it, so you should be able to do them now. If you have any questions, you can always email me or you can ask me questions in class. Does anybody have anything they want to ask me? You can either send me a chat or you can send me an email or you can talk to me in person. Any questions?